My dear students, now we will look at lecture 6 in module 4. Now we are going to design gray to binary conversion circuit, also known as converter. So what we exactly try to do is, we will look at the objectives of this lecture, then we will look at the steps involved in order to convert a gray code into binary code. Then we will develop a truth table. We will look at the truth table. We will try to express output in terms of inputs. Then we try to get expressions for the output in terms of inputs. We will simplify the output expressions using K-maps. Then we will get the expressions from the K-map. Then we are going to draw the logic diagram. So these things are listed in the form of steps. In the form of steps, you can see these steps mentioned. Okay. So the conversion process that we are looking for is gray to binary. Once these steps are clear, we will look at the very first step, the step input output relations, gray code to binary code. Gray code is not in a proper order code. So if you look at this value that we are getting over here, if you look in, so you see here this is 000 is 0. What I am trying to do is I am writing the serial numbers. So I say SL number, serial number. Okay. So 0011 is 3. Next is 2. Next is 110 is 6. Next is 7. Next is 5. Next is 4. Okay. And then 12. Right. 13. Right. 15. 14. Right. So what next? So then it is what exactly the value of this one? 14. Then 10. Then 11. Then 9. Okay. So this is 9. This is 8. These are the numbers that we have. So for this, what exactly that we are need to do is, we need to write the expression. What expression that I need to write is, I need to write expression for a. What is a is? A is a function of, okay, so x comma y comma z comma t. So this a is nothing but sigma m. It is 1 for what exactly? 1 for 12, 1 for 13, 15, 14, then 10, 11, 9 and 8. So if I write in the order, it is a function of 8 comma 9 comma 10 comma 11 comma 12 comma 13 comma 14 comma 15. So this is what exactly the min terms. If I keep these values in K-map, then I'll get expression for a, which is in terms of, okay. So I can say a is a function of x comma y comma z comma t, and which is this, same as above. Okay. So we were going to get expression for a. Similarly, we look for b. What is b? B is a function of same x comma y comma z, x comma y comma z. All outputs are functions of inputs. Now this b can also be written as sigma m. What are the min terms for which it is 1? For which it is 1, you have to look into the table. So if you look into the table, output for which inputs output is 1. Output is 1 for these 4 cases. Output is 1 for these 4 cases. So what are these 4? 8, 9, 10, 11. So 8, 9, 10, 11. What are these 4? Is it not 4, 5, 6, 7? So 4, 5, 4, 5, 6, 7. So if you write everything in the order, sigma m, it is 4, 5, 6, 7, 8, 9, okay, 10 and 11. Once if you are able to write this properly, then rest is only simplifying in K-map. So next is C. C is also a function of what? X comma, Y comma, Z comma, T. So what I need a C, which is sigma m, for which it is 1. So it is 1 for 2 and 3, 1 for exactly this 2, this is 4 and 5, 1 for, okay, what exactly 14 and 15, 1 for, it is output is 1 for what exactly 8 and 9. So can I write the things? First it starts with 2 comma 3, then 4 comma 5, then what exactly 4 comma 5, then after 4 comma 5 what exactly we have 8 comma 9, 8 comma 9, then what we have the other two is 14 comma 15, 14 comma 15. Next is d. So what is d? D is also same thing, it is a function of x comma y comma z comma t. So what is d is? D is sigma m, for which values it is 1? It is 1 for 1, it is 1 for 2, then it is 1 for 7, it is 1 for 4. Okay, so you can write the numbering for which it is 1, then we try to do the process. Okay, so what is that? Those values, we can write those values, that is 1, then this is 2, then after 2 what is that value that we have? 7. Next this one is 4. By looking at here alternate numbers you can write, right? So for 0, 1, 3 is not there, 2 is there, 6 is not there, 7 is there, 5 is not there, 4 is there, then 12 is not there, 13 is there, then after 13, 15 is not there, 14, then 10 is not there, 11, then 9 is not there, 8. So what I can say, if I write in the order, it is 1, 2, okay, 4, 7, then 8, 8, 13, 14, 11, 13, 14. So for all these it is ones. So what we do is we will keep all these values. I need to solve for A, I need to solve for B, I need to solve for C, I need to solve for D. So in the next slide what we try to do is we are going to use those values into the K-map and we try to get the expressions. So now if you look at it, what exactly that is happening is you put the values of A into this map. So what is this value? Just we have seen already. So for A we got it as these index values, you know. So this is 1, 1, 1, 1, 1, 1, 1 and 1. Why it is so? So it starts with x, y, z, t. This is 0, z, t changing 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. Okay, so what are these values? This is what exactly? This is 12, 13, 15, 14. Okay, then this is 101, 10, 11, 9, 8 by looking at these values, right? So I can combine this 8. If I combine them, what is common here? What is happening over here? Over this direction, when I take all these 4 into consideration, 0 to 0, 0 to 1, 1 to 0. So what is changing? Z is changing, T is changing. The one which is changing, that will not be there in the expression. Say for example, here to here, T is changing. From here to here, Z is changing. Any variable which changes, that will not be there in the expression. So here it is 1, 1 and 1, 0. In this, what is not changing? This is in the form of x and y. So x is not changing, y is changing. So the expression for this 8 ones combination is x. Okay, so the expression output for output is x. The meaning of x is, this expression is, after solving, it is saying that the content of x, the content of a is same. It's true. This is what exactly the thing. So both are same. From the expression I am getting the same. So that means we are going in the right direction. Next, if I look at next, what exactly I need is this. I need to enter for output B, for B, values of B I need to enter into the K map. Values of B. So values of B is 4 ones over here, which are nothing but 6, 7, 4, 5. So 6, 7, 4, 5. This is 4, 5, 7, 6. 4, 5, 7, 6. Indices values are 0, 1, 3, 2. What about this? 12, 13, 15, 14. 8, 9, 11, 10. Right? So it is also 1 for what exactly? For which values? For these values also it is 1 for B. So what are those values? This is 8, 9, 10, 11. 8, 9, 10, 11. So if I combine this 4, what is the expression for this 4? Is as it is changing from here to here is there. So Z and T are continuously changing. ZT will not come into the picture. Okay. So X. So what is this? This is X Y bar. What about this expression? ZT changing over this length, and if you look at this here, it is X bar Y. So the expression will be X bar Y plus XY bar for B. Similarly, for C, we need to enter these values of C into the map. For indices values, same as it is, as we know. So it is 2 for 3 and 2. 2 and 3, it is 1 from here. This 2, from this 2, from this 2, and from this 2. We will be getting these 2. I can combine these 2. These 2. What are these 2? For example, this is 2 if it is 4 and 5. If I take this 2, this is 14 and 15. See, this is 14 and 15. Next, if I take this 2, 8 and 9. So this is 8 and 9. Okay. So for every combination, I can write an expression. What is this expression? What is this expression? What is this expression? If I put them all together, okay, I'll get overall expression. So what is that overall expression? Is here it is x. What exactly in the earlier case I got? X bar y plus xy bar. So now I can see here, when two are in combination, I will get a different 4 expressions. For example, if I look at this expression, here what is changing? This is x bar y. This is x bar y. X bar y. What I will get it from here is, what is changing is t. So I will get a z bar. X bar y z bar. For example, if I want to look at this expression, what is this? This is x y bar. X y bar x10. And what is changing in this? T is changing. What is not changing is this 0. So z bar. What about this expression? This expression is, if at all you want to look at, what is not changing in this? This 1 is not changing. So it is z. And where we are here? 1, 1. So it is x, y, z. Similarly, for this, what is the expression that I am going to get? For this, if at all look for, I will get x bar, y bar, x bar, y bar. And what is common in these two? Z. So with this, I can see that this is one term, this is another term, this is another term, this is another. Totally 4 terms are there, which all together is known as x exclusive or with y, exclusive or with z. Okay, this is expression for C. What is expression for B that we got here? So the B expression is x bar y plus xy bar, which in turn known as x exclusive or with y. Okay. Next, what we try to do is, we look at the other last one, which is D. The D is enter the values of D. So if you enter the values of D in the map, okay, so those will be like this. So that is, we cannot combine anything more. So we will write the expression as it is, but it is equivalent to what exactly is known as x XORed with y, XORed with z, XORed with t. So these are all XORed. So this is what exactly the expression. So in the step 4, we have got logical expressions. Okay. Once we got the logical expressions, then we need to draw the circuit diagram. So now what exactly we need to do? From A, B, C, D, we need to get what exactly known as from what are the inputs we have? X, Y, Z, T. What are the outputs we have? A, B, C, D. So we from X, Y, Z, T inputs, I need to get outputs A, B, C, D. So what is A, what is B, what is C, what is D, we know. So say for example, if you want to get A, so you take X, that itself is A. Now if you want B, you take X and Y. So you take X input and Y input, give it to the XOR gate, then you will get your B. If you want C, then you take 3 input XOR gate, For that you give X, Y, Z, then you are going to get your C. Okay, I got ABC. What is D? You take C, so XYZ is there. Or you can take 4 input XOR gate, for which the inputs are X, Y, Z, T, that is T. So this is the circuit in order to convert your what exactly known as gray code to binary code. So this is a circuitry. This is what exactly the circuitry to convert okay, gray to binary conversion. So with this, what exactly the key takeaway was? The key takeaway is the conversion circuit. With this, I'll stop.